You are watching my channel TechZone and DIY. Please subscribe to my channel if you have not already done so. Thank you very much. Hello folks, so on demand I'm making this video about the cold room connections. So let me explain how things are, because in my video I think the connections are not so deliberately discussed because videos can get really long. So now I'm drawing all this stuff on the paper. So this will demonstrate the entire setup, how you're gonna hack the window air conditioner on a low level. So there had been a question being asked that do I remove the connectors from the thermostat? This thermostat, though this thermostat is pretty useless for me, but I don't, and there is a reason behind it. On the thermostat there is a flat connector where you can slide in this type of connectors in there. So what I do, I put the wire here like this and then I slide it in. So what happens, I don't have to solder this wire anywhere, or I don't have to crimp this wire to the original wire. It just snugs it. If you push this in onto the connector, the flat connector, this wire gets stuck inside, and you don't have to keep it short, you have to keep it long, this long basically. That accommodates the entire stuff. So this is one of the things that I wanted to discuss early on in this video. Let me go back to the main parts of the air conditioner. So this is a switch, on-off switch. So it's a rotary switch or any type of switch. So this is a main hot wire or live wire, if you want to say it live, that comes into this switch, and the neutral goes directly to the capacitor. Okay, so this capacitor is made that way. There are many connections, but you have to find this neutral wire. Generally this is white wire. Okay, from as soon as you switch on, then what happens, the live wire, when the switch goes to cold setting, then this switch engages here, and then this goes to the one connector of the thermostat, right? And this wire goes to the live side. It's a capacitor, it's AC capacitor, so it doesn't matter which point, but this is live. And this thermostat, it has the sensor which goes to the inside radiator for the air conditioner, and when it gets hot enough, just a mechanical switch, so this engages, and then it goes to capacitor, and then from capacitor this goes to compressor, and the compressor turns on. So I am taking one connection from here directly. So I will keep marking. I will put this connector goes here, and it goes all the way in, and this connects to the cold point of the Inkbird. So Inkbird is pretty simple. It has 6 pair of connectors. One is main, where you have the hot wire and neutral wire connected. Then there is a sensor port, and then there is a cold point, and there is a hot point. I did not mention the hot point here because I just mentioning the cold point. The Inkbird will tell you which is cold, which is hot. And similarly on the other side, same thing, you have 2 points. Normally same thing, but I'm just for the purpose of demonstration, I'll making it to the left side, this right side, but actually they are in the center. And then we have a hot sensor here, and then hot point. So it also has cold points in between here, and this also has a hot point somewhere here. So I'm not mentioning that because that will make things more confusing. So I'm just taking the hot point, and those points are connected through a relay. So as soon as the temperature rises, whatever is set up into the display, then this relay engages on the cold setting. So this will get engaged on that specific setting, and then this wire will go in and this wire will get connected to this connector. All right, so what's happening here is this live wire will not have any current until this switch is on the cold setting. Okay, so you want to make sure that this is on the cold setting, then only you engage the compressor. So you are not bypassing the security, you are using the security. For example, if this air conditioner is on fan only, then this cold point will not be engaged and this thermostat will remain disengaged, and similarly the Inkbird will also remain engaged. So as you had seen in my video that I put a cold point here which is outside the grill, and this one actually is getting connected all the way, getting connected to the cold sensor, and the hot sensor is inside the grill, deep inside, and this is for hot sensor, and this goes in here and this connects to the hot sensor. All right, so this diagram for now is pretty simple. There is absolutely no, this is not difficult to understand. Okay, so what is happening here? So as soon as the temperature rises from the settings that we have made, this relay will engage and this will connect to the thermostat live, despite the fact that this relay is probably still open state. It's not a closed state, but I have given the feedback to this wire, which again does its own stuff inside the air conditioner. I'm not going there. I'm just giving the current to this point, the voltage to this point, and this switches on the compressor. All right, I think this is very clear. So as I mentioned that these are the main points. So there is one hot or live point, and there is one hot live point, doesn't matter which one you select, and then you give this connection from the mains. This comes from the main connection. Similarly, this goes from the mains connection for the air conditioner through its own cord, and then you make those the hot side and the cold side for the Inkbird. All right, now I have interjected something. This is pretty nice. This is simple. If you don't want to introduce the heater, then this is pretty much what you need. Okay, you don't need anything else over here. But because the temperature for this walk-in cooler is gonna be maintained at 1 degrees or 2 degrees centigrade, which is 33 or 34 degrees Fahrenheit. So keeping that in view, this grill is gonna ice up for sure, 100%. So you have to put in a heater. So whenever this ices up, you don't have to really switch off the air conditioner manually and then look for the ice. That's cumbersome. That will not work, and your AC will not work. It will just will not cool down your room, and your things can spoil inside. So you have to introduce some sort of a heater, which I shown in my video, which is very small heater, this big, but that does its job very well. You can put in 2 heaters as well if you have a larger air conditioner. So what happens in the heater, so I'm putting one hot or live wire and this is neutral. So I'm taking one wire from here, from the neutral, or from here, any point, but generally there is no connection, it always goes there. So you make a connection from here and you put a wire neutral. So neutral is connected from within air conditioner, right? However, now you have to make changes into this circuit here. So this wire will not go like this. So this was good as long as your you are not installing any heater, but because heater is almost necessary, so this point will not go anywhere. So I will just remove. So from here it will not go directly to this point. Now comes in a relay which is 110 volt for the North America, but whatever wherever you are, you can select your own voltage. So this is two pole. This relay has to be two pole relay. One will be the cold side, one will be the hot side. Okay, in this relay is energized by this is main or live and this is neutral. Neutral will be connected to the neutral of the Inkbird, whatever the neutral is. You can either take it from the mains or take from these points here, doesn't matter. So this neutral will be engaged already. All right, so what will happen here, then this thing will go to the one pole of the relay or one side of the relay to the normally closed. This is normally closed. So what will happen, as soon as the temperature rises, this relay will engage, it will go there and make the circuit here, and then from this normally closed point you take this wire and then you make this connection. So then this will go through this relay, it will get connected to this one. Now I will tell you the reason why it is so. All right, so the reason for this one is that once the radiator ices up and you have set up the other Inkbird, that as soon as the temperature drops to, for example, -4 degrees centigrade, then this will engage the hot point and the heater will come on. Now if you do not use this relay in between, what will happen, the cold will keep running and the hot will also keep running, and resultant is you are not going anywhere. This is heating up, this is cooling up, so nothing will happen basically, or it will be very slow process. So in that case, what has to happen, that somehow as soon as the hot point comes in, you need to disengage this point. You have to disengage the compressor. Okay, so this is where this relay is coming in. So what happens, so this heater is getting connected to the hot point of the relay, right? So one point of the heater is connected to the capacitor neutral and the other point is connected to the hot point of this relay. Now a tricky part comes in, that you have to take this hot point from here and you have to connect to this one. So let me now see, this is where it gets really difficult to manage or to draw the stuff. So you have to be careful. So you take this wire, you take all the way up, all right, and you take this one and make a connection to this wire, or you can directly connect this point to this point, because you have to take this both settings should only work when the switch is on cold setting. If switch is not on cold setting, then it's terribly cold somewhere, and your cold room is already in -4 or whatever, theoretically. It may not be the case, but theoretically. So what will happen, this hot will come on only when this switch is on. All right, so this one will be connected to this one, and this wire is also connected here, or they will be close by. These are very close together, so you can just jump a wire from here to here. All right, so this is in, this is out, this is in, this is out. Right, it's mentioned on the Inkbird. All right, so now what happens? Okay, so as soon as this reaches to -4 degrees centigrade, what will happen? This relay will close. Okay, now this, as soon as this relay closes, then from this point you have to take this out and connect to the main or line side of the relay. As soon as relay gets this 110 volts, this will engage. As soon as this relay gets engaged, now this connection here, which is normally closed, will disconnect and it will go to the normally open state. So normally open state will close. Okay, so the current will start flowing like this. Okay, so this is when it is hot settings, and this is when this is cold setting. So now there is no current going to the thermostat, so compressor is shut down. However, okay, what will happen in here, because you take this out, and the same connection from the live, you will take this wire and connect to the other side of the relay. Okay, and now I will show you, I will remove this stuff because that I had drawn for understanding how the heater is working. Now this has this point, this wire has to be connected to the normally open side, because as soon as this relay engages, so this point is not there. Okay, because you have to take it out from normally open. If you like, this will also work as is. This will also work as is. But for a standard practice, how do you manage these wires? So there are some standard practices whereby you make the connections the way you really want them to be on. So this line will go in here, and then this will jump this line, it will jump this wire, and then this will jump this wire, and then it will get connected here. Okay, so this normally open is being connected to the other side of the heater, right? Though the original setting will also work, mind me, this will also work. Okay, so if you do not find a 2-pole relay, even 1-pole relay will be able to handle the job. Okay, but what is important in here, okay, as soon as this relay gets engaged, this 110 volts should go to the relay to open up this circuit. Okay, so normally closed will open, and then the compressor will shut down. All right, and but what I had done is I did it like this. so that I following the standard practice here, normally open, normally close, normally close, normally open. So this point is connected to the normally open on the other side of it, and this is normally closed, because this is two pole relay that I have, but one pole relay will also work. There is no harm in that. Only thing is that you have to get connected this to this one. All right, so either this one you have the option, okay, you can also directly connect to this one, okay, or you can take it from the relay. It doesn't matter. The only benefit is this one, that as soon as this relay drops, this relay will also drop, and this connection will also drop, okay. But because this relay is dropping anyways, so you can take it directly to the heater as well. So there is no harm. There are two ways to do it, right? There can be some improvisation on this circuit, which is pretty nice, but I am keeping this portion totally segregated from the hot side, okay. I do not want, because there is a relay in here, so this relay and this relay work the opposite way. So you cannot do one thing, that you take out normally closed for the compressor and normally open for the heater, because these connections are governed by this relay. So if this relay is off, okay, because your temperature is too cold, okay, so there is no current flowing here, and normally open will not work. Okay, I think that will make things very clear. So I will take a picture of this one, and I will post it on my video. So so this is AC hack for cold room. All right, guys. So I think that explains everything. And let me know if you want more help into this one. But this circuit for me is working perfect. Absolutely no anomalies whatsoever, and I did not solder anything because I am directly connecting these wires in here. For the heaters, yes, I did solder and heat shrink with a heat shrink tube, like these tubes, heat shrink tubes. So whatever connections I made in here, I soldered and put a heat shrink on top of it, this one. So it's not waterproof, so you have to be considerate, because the wires in the heater, they are dipped into high temperature silicone. So this heater itself is watertight, or I don't know whether this is waterproof, but I think this is waterproof. However, the water is not gonna damage this one. So, but these connections, these wires are pretty long, so I'm keeping them from harm's way, away from the icing stuff. So I'm just keeping it raised a bit, so that no water goes into the connections. All right, I think that explains the entire circuit now. All right. Okay, thank you very much for watching, and have a good one.